Going live. It says I'm live. Do a little bit of test. Jeremy's going to check and see if I have some audio working. 1 second. Dun, dun. Testing, Jer. Can you hear me? All right, yes. Jeremy can hear me. That means you can hear me. Everybody can hear me. Everybody. All right. Where are we at? Let's go. Desktop view. Okay. I got some bolts here. I was gonna say screws, but they're not screws. Otherwise, I'd be like, "Hey, Jared, do you want a screw? Do you want a bolt? Sure. Let's bolt, Jared." All right. those are whatever, a 1/4 inch, because they're needed for this camera that I got on K8 robot. So I needed to mount, so I 3D printed a new bracket to hold the Intel Realsense cameras and this USB cam. And I needed to put this in, but it was too long, so I had to cut it with a hacksaw. I did that in the back, in a vise, and it was fine. So that's the setup for it. So now I got this little guy for spying on you. Hey, David Snuffleupagus, how you doing, buddy? So I'm just gonna clean up a few things on my desk here because it is a disaster and it's just getting worse. I swear, every week I say, I'm going to clean up my desk, and that doesn't happen. It just keeps getting worse and worse and worse. Okay, BRBs. See these cameras? No. 110 view wide angle. Haven't tried it yet. Yeah. What's that? Super cheap? Yeah. Here, I want you guys to see something. So, on this robot, on Kate, which is my dev platform, and on this robot, which is my Turtlebot 3, I'm going to be adding one of these cameras to the Turtlebot 3, as well as it has the brackets in the front for the Realsense. But I'm not going to do that today because I have to 3D print a whole new bracket for it, and I don't want to 3D print anything today, unless Jeremy feels like doing it. But, oh, what's he doing? What are you doing down there, Jer? What are you doing?
Everything's plugged in.
Ah, that's Jeremy's new home down there. That's where he's living. It's his little hideaway.
I stay here during the week and then come out Fridays.
Jeremy comes out of the, I guess that's not the, he comes out of the cupboard. Yeah. Okay, so this, anyway, what I wanted to show you, this is the camera that's on my Kate, the dev robot, and I ordered 3 of them because they were so cheap. They were $19 on Amazon, which is crazy cheap, and it's in Canadian dollars. So in US, that's about $1.50. And what's neat about it is it's got a 110-inch. I don't know if you can see this here, but it has a 110-inch wide-angle view lens. I haven't actually used it yet because right before this live hack, we went and had dinner, and prior to that I hooked up the camera, so I haven't actually even plugged it in. So we're going to play with that today. We'll turn it on, but let's open up the box and show you what's inside. So it's good to see what you get for $20, whatever it was. Open this side, I guess. I could never return anything from Amazon because I always end up ripping the crap out of it. So this was nice. This is a little sticker that you can put on the top of, on the lens of the robot to cover it up so you can close it and open it. I'll show you it here. Isn't that nice? Book, book, book. And come here, you. Let's see what else we got in here. Oh yeah, look at this. a little stand. So if you're using it on your desk or something, like I don't get how these companies can make any profit off of shipping a camera like this for so cheap and including all these peripherals. So that's super nice. This will probably come in handy for, like I mentioned, I ordered 3 of these so I can use one of these on a different robot or on my desk for testing. Because unlike you guys, I'm always jealous. I think I mentioned this before. You're always getting to build robots, right? You guys are always building robots. Snuffleupagus over there is building all these big B8 robots and is that what they're called? B8? B9 robots. Dave, apologize. I was never a Lost in Space fan, but I'm gonna get there one day. One day I'll have nothing else to watch, and I'll end up watching some Lost in Space. But anyway, I don't get to play with robots very much, so that's why it was so important to me to be able to build this, so that I can have so I can have robots to play with while I'm doing actual real work. And of course, my real work is making it so you guys can build robots. We do have the robots in the Exosphere lab, and those are the ones that we generally use. But those ones I can't really take down to program, right? Because they're being used all the time. So this is what the camera looks like. It's nice. It has, like I mentioned, this is a 1/4 inch, and it's a coarse thread, whatever you normally would use for a camera tripod. 20 threads, I don't know, some number. Let's go to Home Depot and keep trying it till one fits. That's what I did. And there you go. And we can stick this on there now, might as well, because we're here. It has a microphone built in. I don't know. We're going to find out if it has a power LED. It's hard to tell by it's got a picture of a power on it. So you'd think there'd be an LED there, but you never know. It is China. I don't know why I say that. Everything is made in China. Everything's made in China. I think some people probably want to put it sideways. Some people maybe put it this way. I'm finding it going this way makes more sense to me. And you flip it up. Yeah. Okay, so let's throw this back in here, this baggie, because I'm going to put it in the box with this. And someday this weekend, I'm going to 3D print another one of these brackets, and I'll put this bracket on the TurtleBot 3, because the TurtleBot 3 is even though I can use this one pretty much for everything, it uses DC motors with encoders with a Sabertooth, and this one uses Dynamexel servos with a Open CM or CR, one of the two, whatever the bigger one is. Let's see if we can get up there. There we go. Microcontroller. And then we use a Rock Pi X, of course, because the Rock Pi X is the best. And I even ordered a few more Rock Pi X's. Yeah, I'm going to put Rock Pi X's on everything. I'm going to start wearing Rock Pi X underwear. They are the best. I'm just super surprised that they don't get... Well, I mean, I was going to say they don't get a lot of press or attention, but they must, because they're always sold out. Yeah. Yeah, so Jer, of course, is sitting over here next to me. So here we are. Here we are playing around. So let's close this up and let's play with some robots. I can't close this up. I have a better idea. How about this? Boom. There we go. Okay. I literally threw it. I'll throw this over there too. Lots of throwing going on. Okay, I don't think we have anything to do with this today. Like I mentioned, let me think. I mean, it does have the LiDAR on it. I don't know. I don't find LiDARs exciting anymore. I used to, right? Because they were LiDARs, they were cool, they were lasers. But I mean, now that I have the Intel Realsense, this one, which does depth camera, I just don't really have a lot of excitement for LiDARs anymore. So I don't know if I want to play with this right now. Maybe we shall play with it another time, or maybe even later tonight. We'll see. Because what we can probably do, because this sits pretty low, it doesn't sit higher than this, it doesn't sit higher than this. So maybe what we could do is we can put some standoffs. Put some standoffs under here and raise it up higher than the rock pie. And then that will give us quite a bit of room. Also, I have the rock pie pretty high off the board here. I bet you we can lower it by removing these standoffs and bringing it down another. Looks like about 1/4 of an inch it can go. I don't know. Maybe. Let's put this to the side because we're going to play with the other robot right now. I'm just going to throw this on the floor and we'll use it as an obstacle. Okay, let's take a look at the real robot we're going to be playing with tonight. Right here. Now, before we begin, I wanted to make a quick update to the robot skill for the T265 tracking camera. And let's do that before we play with the robot. Let's dive into some code and I'll show you what it is that I'm going to want to do, because it won't be very complicated. Let's look inside of controls here. We're going to check this in. What did we do? What did we do in this thing? Let's see. We added, option for enabling, disabling build map. And we added option for trajectory history count. And let's jump into the Intel Realsense 265. By the way, today's refreshment for me, because I drink real beer and Jeremy drinks coolers that he got from my mom. This is an Innocent Gun Scottish bourbon barrel Scotch ale. That's a lot of different words, eh? Bourbon barrel. Anyway, this is one of my favorites right now. It's fantastic with a V, capital Van. Jeremy's drinking nothing. He ran out, but he had a cider.
Summersby, the new one, mango and lime.
He's been drinking mango and lime. Problem is that I bought a pack last week of these, a case, and then Jeremy bought a case of Summer Bees, but he finished his case before I finished mine.
You had more in it.
I had 6, and you had 4, and yours are bigger, and I gave one to Royal, so probably evened out. Why don't you go to the beer store real quick? Nah, Jeremy's not interested.
One's enough.
David Snuffleupagus says his mom has him, or his wife, his mom. Sorry, Dave. His mom has him drinking red wine. That's what I was going to say. His wife has him drinking red wine. Is it good for your heart? Is that why? She wants to keep you around? That's a good sign. It means that the life insurance policy hasn't been approved yet. Yeah, that's what I hear. I'll tell you, I can't drink red wine because the first time I ever got drunk in my life, I think I was 13 years old. It was a horrible mistake. I didn't understand alcohol at the time, so I had a box of red wine that was out at my cabin that my grandfather left out there, and I made, my friend and I thought we were gonna have like a fancy grown-up dinner because we were kids, and we opened up this box of red wine and started drinking it while we were making craft dinner, having this like gourmet meal. And next thing I know, I woke up in the morning, and I have, to this day, I have vague flashback recollections of things that have happened. I remember running around in the water with my clothes on. I did throw up because I definitely saw a lot of throw up in the morning. It was a pretty messy morning. Anyway, I drank red wine that morning, and I have not been able to since I think I was 13. Since I was 13 years old, I have not been able to touch red wine again since. It just, it was a horrible experience. Even the scent, or sometimes, like right now I'm okay, but sometimes even the conversation about red wine, it's just, there's something in it. It's like, remember that movie Clockwork Orange, where the guy's eyes are held open and they're trying to reprogram him for violence? That's what I feel like. I feel like I've been reprogrammed to never drink red wine again. Dave says he lost a car like that once. Dave, I feel like we should give you a microphone so you can tell us that story. I think Dave just took the entertainment value of the evening. I did not have a car. I don't want to say this on the camera though, but the next day after drinking that much, was the day I lost my virginity. Yep. Yep. And the only reason why I think that happened was because my friend took the blame for the vomit, and my girlfriend therefore was not disgusted by me. The bad news is that in order to lose our virginity, which we prepared for a long time, it was at my cabin, right where my couch is today, to this day still. But it was to Sinead O'Connor's, what was that song? Everything I do for you, or whatever. Is that the one? I don't know if that is. No.
Is it Brian Adams?
No, it wasn't by Brian Adams. What was the other one? The Sinead O'Connor one. The very first one that she got like super famous for. Super whiny. She was just like, every something. Jeremy's going to look it up. So that was one song. Man, we really got on a tangent here. Because how did we get talking about the music I listened to? The first time I had sex, I think. And then the next one was it was a song from Ghost. It was called Righteous Brothers, Unchained Melody. That's them. And then the last one was Wicked Game from Chris Isaac. Those are the three songs. Dave says his wife is here, he'd tell how he lost his virginity. Dave, was it in the car that you lost?
There's no tracer record.
There's no tracer record. You had to burn the car after that night. Sinead O'Connor. What was the song called? Nothing Compares to You. That's the one. See there, I got all these like PTSD in my head right now, I guess. Drinking all that, and then okay, so what am I doing on this? What I'm doing on this particular control is we're going to add in here a button, and this button is going to be smaller than this other button, and we're going to bring this forward here. We'll put this button underneath, make this button a little bit smaller as well. Okay, and this new button that we're going to use is going to say the word reset on it. And what that's going to do is it's going to reset the position to 0. Now there is a control command that does this, but I just want to be able to do it real quickly with a push of a button. And what we're going to do here to reset it is in the, here we go. We'll just copy this bit of code here. And then we'll put a if message box dot show reset position to 0, 0 at 0 degrees. Reset. Yes or no or cancel. If it doesn't equal yes, then return. And these values are going to be 0. So that's the wrong code copied. We want this one here, reset to 0. Boom. Okay, that's just really simple. This just allows us to be able to push the reset button and reset the position of the robot back to a 0 home. You can do it, like I mentioned, you can do it by control command. That's where I actually got this code from. I got this code from the control command, which is right here, send command. So when somebody says reset to 0, that's essentially what it does. I just copied that and put it there. Not a big deal. So let's rebuild this. Oops, let's rebuild this file. Increment it version to 22. And let's upload it to the website. And then this is the file we're going to use tonight to play with here. Oops, what do I want to do here? Skill store. T265. There she is. Edit. Upload a file. Realsense. Go. 22. There it is. Poof. Rock and roll high school. Okay, so we're golden. Cherry pie. I'll write into here the description just so that people like Alan know, because he seems to be excited about all these things. Alan's like, yeah. Yeah. Look at that. I think this is what I heard coming from Dave's cabin up in the north. Yes. Sorry, Dave's wife. Okay, so I think what we did here is we added a button to reset to 0, or reset position to 0, rather than you having to use the control command. That's just convenience. Because I tell you, the reason why I came up with it is I was using the home to 0 with a script yesterday, and it was getting kind of annoying, so I figured I'll just add this button. Okay, let's show you what I've done with this robot that I posted on the website here. So here are pictures and a description of the robot that I've built. Pretty good looking robot. Hold on, I have to respond to a text message like a little teenage girl. There we go. Okay. What? What did Dave say? No, her dad was in the next room. Oh! Oh, geez. So there was no yelling yes, that's for sure.
Wow, Dave is a bold man.
Dave is a very bold man. Okay, Dave, you are now the hero. We're going to get a picture printed up of you. We're going to put it up on the wall. This is just such a good looking robot. Wait till you see it. It's awesome. It took a lot of work. It's running the Devastator tank mobile robot platform. It is using these wheel encoders. Jeremy and I had to, after the last week's live hack, we had to do a lot of work to get those wheel encoders working. I don't know if you remember, but we couldn't get it to drive straight. It was running into a whole bunch of problems. And that is because this is the gearbox, two of the gearboxes that we took out of that tank robot. And these DF robot gearboxes are, I'm sorry to say this, I mean, it's not very technical, but they are garbage. They're cheap, they're plastic, they're sloppy. Everything about them is not very good. But that didn't stop us from getting it to work. I mean, we definitely got it to work. You know, we just added an Easter egg to it here, and we just made it work. So this is the remnants of took 4 gearboxes and made 2 that worked.
I think it was the Cadbury magic that we have.
The Cadbury, yeah, we had to lubricate it with the Cadbury magic here. Where did this come from? Am I going to eat something I just found on the desk?
Yes, I brought it to you last week, but you left it there.
Did you bring 1 or 2 last week?
I brought 2.
You must have brought 2 because I ate the 1. Well, let's open this up. What's in this thing?
2 for each of
Oh yeah. Look, it's got air in there. It's hollow.
Oh,
I know.
that's okay.
All right. I thought maybe the Easter Bunny left that for me. I said it was the Easter Jeremy.
That's such a weird thing, the Easter Bunny. I looked up the origins this year.
There's an origin to the Easter Bunny?
The Easter Bunny does, the fabled Easter Bunny does lay eggs.
Really?
Yeah, that's the part of
The original Easter Bunny laid eggs.
part of the myth. And
You know why it happened, right? Because you heard about Jesus coming back from the dead and he shit himself eggs. Oh my God, it's a zombie apocalypse, he said.
although eggs do have like a symbol in Christianity, that was an interesting part.
Do they? What do the eggs symbolize in Christianity?
It symbolizes like a rebirth and like.
You mean it symbolizes what it actually is? Come on, you gotta do better than that. if an egg symbolizes rebirth in religion, then come on, religion. You can do better. That's what the egg is for. Okay, so let's go back to this. What we ended up doing is we found out that one of these motors didn't spin very well. They both seem to, yeah, it's this one here. This one's not spinning. You can see it's not spinning as long after I spin it, where this one is spinning for a longer time. So this one was slowing down the one wheel and causing it to turn. Now, something to consider here is that even though these wheels now the motors spin at approximately the same speed because they've been replaced inside the new gearbox, there is going to be a little bit of drift. So that's why I went with the Kangaroo and Sabertooth combo. So I can use the encoders that are on these gearboxes, and the Sabertooth is supposed to keep the robot driving straight and do speed control. I think it does a pretty decent job. It's not perfect, but it's pretty good. It's and you need, I guess, having a little bit of turning is okay because it allows us to test and make sure that all our code is working fine, right? You definitely want to have some errors in it sometimes. If everything's perfect, then so anyway, so these are the leftover pieces from that gearbox. I don't know what to do with them. You could probably put two together. They just won't work as well. Jerry, do you want these? Sure. Yeah, Jeremy will take them. He'll put them together. Do you want to take them off my desk and onto your desk now? Do you think they're gonna go on there?
Load me up.
All right, Jerry. Let's see. There's a hole in the middle, Jerry.
I know. That's what I
Got a hole in your bucket, dear Liza. Dear Liza, there's a hole. I don't know. Some of these screws I think are for you.
Okay.
Oh yeah, I think all these screws are for you, Jer. Yeah, everything here.
Fill up my bucket.
Everything here is for you, including this screw here. Yeah, and even this solder sucker. That's part of it too. Oh wait, there's a capacitor here.
I'll come back for that.
Here, I'll throw it at you. There we go. Jeremy's got it. Here's the battery pack, nicely fully charged. I still have yet to drain this thing. I can't drain it. I try.
Yeah, what's it at? What percentage?
It's 100% now. I recharged it today. But when I came into the office today, it was 93%.
That's it?
And I had been using it like so much yesterday. And I didn't charge it. Yeah. It's crazy. So let's take a look at this robot. This is what this night is all about. It's about robots. Hold on, I got a loose camera up here.
Loose cannon.
Yeah, gotta tighten it. There. We're teat. Okay, so let's go over what I've done with this thing. There is, like I mentioned, the two Intel Realsense. This is a T265 down here. This is a tracking camera. This has internal SLAM, so it's inside-out detection. It tries to figure out where it is. We are having some communication challenges with Intel right now because they suggest inside of the documentation that you pass it odometer information. That's the encoder wheel information. And There is not. There is an example in Python. There's nothing in C. There's nothing in C#. There's no other examples. We're having a hard time trying to get that. And they're saying, oh, we discontinued it. So promoting a product feature, but then not following through on it is super uncool Intel. So we would like to be able to pass the encoder data to it. So hopefully we'll get that ready for you soon. That should help also add some more stability and accuracy to the pose information that this is returning. This one. Then the top one up here, this is the depth camera. This one essentially creates a depth image, and it's a 3D image, and then we turn that into a laser scan, which we use into the NMS navigation system to be able to see what the room looks like, so we don't run into stuff. And then this is just a regular camera, which we'll turn on for the very first time and see what it looks like. We covered that at the beginning of this episode. And we'll see what the video of it looks like and see how it detects colors and stuff. Finally, powering this whole thing, we're using the Rock Pi X. And it's this one here, I think, is the 32 gigabyte version. So got lots of gigs. It's got 4 USB, which we're using all of them. One for all 3 of these cameras in the front, and then one final one for the Arduino that's down here. The USB 3 is being used on the Intel Realsense depth camera because it is a USB-C, which is USB 3. There was a question that someone asked on the forum about USB 3 or using the Realsense with USB 2, that it can kind of work. And it's true, it can, but it's crippled when it does so. So I don't want to have to modify the robot skill just to have USB 2 capabilities that are crippled. It's a weird resolution. It's like 4:3 resolution, like you're watching an old TV from the 1990s. 4:3 resolution. It's 640 by 480, which is, useless. As well as the frame rate's like 6 frames per second, and there's a few other things that are kind of bonkers with it. But it also said that the frame rate, because it's going to be so slow, the lenses are open longer, which is kind of weird. You think if the frame rate was slow, it wouldn't have anything to do with the lens time, but I guess it has longer exposure time, and therefore everything's really blurry. So all motion is super blurry with it. And of course I tried it, right? When I was like, oh, I can lower it to a lower frame rate, but yeah, it just was an ugly experience. This is a Pro Micro here. This is the Arduino that is hooked up to the Rock Pi X. And the reason why I'm using the Arduino rather than just hooking the Sabertooth and Kangaroo up directly through a USB to UART is because it's mounted on a breadboard that Jeremy gave to me for my birthday. And what's neat about the breadboard, just allows me to be able to plug things in and test it. So if I wanted to test different sensors or anything at all, I can just prototype. So this has the firmware on it for the EasyB Arduino Leonardo firmware, because Leonardo and the Pro Micro they're pretty much the same thing. They both use the same 32U, whatever it is, U4 chip, which can emulate USB. And way back there, which you can kind of see, you can see better pictures on the website, but there's the Kangaroo. Behind that is a Sabertooth. And again, it's configured for independent mode. Means that there's a couple different modes you can put the Kangaroo in for moving a robot. One of them is independent, which means you can control each robot or each motor individually. The other one is called mixed mode, I believe is what it's called. And it allows your robot to do more of a tank style. And if you look at this, you'd say, oh, it's a tank. But really what they mean is that one channel, so channel 1 will say, right now channel 1 is for this wheel and channel 2 is for this wheel. Okay? So if I set the speed for channel 1, it sets this wheel. Set the speed for channel 2, it sets this wheel. But in mixed mode, channel 1 is used for just moving forward. So it uses both wheels to move forward. Channel 1 moving the other way makes it go backwards. Channel 2, however, causes the robot to turn on a spot. What you don't get from mixed mode is the ability to gradually turn while moving straight, while moving forward. Okay, so if you're moving forward and you want to gradually turn, you can't do that with mixed mode. You have to do that with independent mode. So I had a lot of difficulty understanding that with the Kangaroo documentation, or lack thereof. So that's that setup there. The other thing you'll notice in here too is when I turn this wheel, you see that wheel encoder here spinning. So those are the wheel encoders. They got little sensors next to them. The sensor alignment really made a big difference. You have to make sure that the sensors are close enough to be able to read. They have to be almost close enough to rub. They're almost rubbing the material that's spinning there. Except you don't want them to rub, because if they do, then it actually slows down the wheel. So you can see here how close I am to these. Very, very close. So you just want to make sure if you have any wires back there, you're not hitting them and knocking them off. Okay. Let me grab a couple batteries or another battery for this thing, and then we'll power it up and we'll start playing with the robots. So there is 2 batteries this thing uses. Jeremy gave me the idea for this because he was like, why are you trying to power the motors off of the same battery that you're running the computer off of? Because the motors are doing all sorts of crazy things, right? The computer is a solid state device that requires pretty stable power output. There's no need to be hooking the motors up to the same power source. So we're just using just a little lithium polymer battery here. It's an easy robot battery. They're like 1300 milliamps. You can use any one that's 7.4 volts. Pretty good. Yep, Jeremy just noticed I mounted the antenna, which is cool. Oh, and you might be asking about this thing. This is I mentioned this in the last episode. This is a HDMI adapter emulator. So this emulates a monitor hooked up to the video card, because a lot of video cards won't actually produce a desktop, or because they don't have a valid resolution. Because if you think about it, if you have nothing plugged into this at all, there's no HDMI, Windows or whatever operating system you're running has no idea what to output. It has no idea what resolution or anything. So they usually just blank the desktop. And then this one here is going to, this is audio. This is just a headphone jack. And there's a amplifier right here, an audio amplifier. It's 5 volts. And then there's a speaker right here. And that's it. So let's power this bad boy up. Yeah, the amp it's not as loud as I was expecting it to be, but I think it's a good volume. I wouldn't want the amp to be any louder than what it is. Oh, wait, I did lie. So here's how I currently mount this battery. I just put a zip tie here in the last episode, and you can see it slides in, but there's nothing holding this side of it. So I'm going to 3D print something for this, but in the meantime, I do want this just to be held a little bit better. So what I was thinking of doing, I have another zip tie here. I was going to try to see if I can feed this zip tie through here. Just kind of do the same thing I'm doing with this one, just so I can hold the front and back. So I'm gonna see if I can do that here. I'm gonna have to use something, maybe a pair of tweezers. I might have to use my special famous pliers, Jer. Maybe I can come up through here. My bendy pliers. Kinky pliers? Oh. Yeah, they are kinky. Come on, you. The only thing that I do find is difficult using this chassis is the metal is like CNC'd, and it's so sharp that everything you put in these holes gets caught. You know, it might just be easier just to take this thing apart than try to do this, but we'll see. Let's see if we can make it happen here. These are my famous bent pliers, my get bent. What? All right, let's see if we can get this in the bottom one down here. I feel we can do this. I think we have luck on our side. Let's get in there, you. Come to me. Come, no, don't go there. Come to me. I wonder what we can put in there. Maybe this. Oh yeah, who's your daddy? It's me. I'm your daddy. Come on, you. Oh yeah, now we're cooking with fire versus cooking with not fire, which wouldn't be cooking. That would be sushi or a sandwich. I did. I saw Dave's question, but I think Dave's question was asked after I had already talked about, or he must have seen it before. Yeah. I talked about mixed mode. Oh, okay, gotcha. Because I did talk about mixed mode, then the question showed up. That's the difficult with this chat, is if you're behind on the chat stream. Okay, look at that. There. You know, it's probably easier just to 3D or design something on SolidWorks and 3D print it than go through everything I just went through, but hey, that's how we do, yo. I'll cut this. I think this is what we want. It feels like maybe a little bit. Yeah, that feels good. It's not going anywhere. Okay. Cut this off. Okay, now we don't have to worry about this falling out anymore. So where were we? We were with this. We got the battery. Oops. Tuck that in here. And you'll notice that we have a fuse here as well. That's super convenient. And a switch. A power switch for the battery for this. Here's our switch. And that just turns on going to the Kangaroo. And then we're going to power up. We'll plug in the battery pack here. And run this up to the Rock Pi. Voila! Now we just wait for this bad boy to boot up. So it's powering up. You're going to hear two things. You're going to hear the sound of Windows starting, because I added a Windows sound to it. And then you're going to hear another sound, which is going to be the robot speaking, and it's going to say whether or not it has connected to the network. It's using a new robot skill, which allows us to detect network changes. Oh, there is a light. Okay, so that was Windows starting, and right now we should also be having ARC starting. And then you're going to hear it speak and say whether or not there's been a network connection.
Unable to connect to the network.
Whoa, that's not the
TCP
news.
connection successful.
That's not the news I wanted to hear. So it cannot connect to the network. I wonder if, I wonder why. Let's see here. We got making sure that our cables.
Network connection successful.
Ah, there. Now it's successful. So when it first booted up, it wasn't connected to the network for whatever reason. I think it might have just been the, I don't know if you saw that, but there's the antenna has a, here, I'll bring it down, a little plug that hooks up to the board here. This right here, it's a very small little one. And I think it was just loose because I just put my finger on it and tightened it up and then it connected. So we're back in Baznas. All right, now before we start doing anything with this guy and driving him around, let's connect to him. So what we'll do first here before I connect, I want you to see what it looks like with the top off. So here is the Arduino we talked about. That's connected with the Pro Micro, and it's got its two wires connected to the Kangaroo, which sits here, and the Sabertooth is here. These are the motor outputs to each motor. And then finally, these are the encoders with the DC motors. So Perry says he's got a 1/16 scale of an M64 pattern that those tracks and wheels came off of. No way. So they stole them from another product? M46 pattern. Model. Oh, look at that. Similar, eh? Cool. Okay, so let's we can close this down. Let's connect to the robot through VNC. Here we are. We got a couple things running here. The navigator, Realsense. So I noticed it didn't check for. Oh, because I should run it. I have to run it by hand here. Let's run ARC manually. And it should check the internet for updates. Yeah, here we go. Here's some updates. I do have a ground attached to it, David. Here, let me show you on the picture that I was just showing you. So David asked if, I just made a comment, so he's surprised there's a ground connected to the room. There is. It's just not where you think it's going to be. Okay, so this fuse is what is powering the Kangaroo and the Sabertooth, and the Arduino is powered by the USB from the Rock Pi. These two wires here are going to the Kangaroo, and they're just signal wires. That's all there is. However, the ground that's coming from the battery is shared with here because you can probably see it just a little bit. It's hard to see. You can see right here there's a wire coming right from this board to here. So rather than running the ground from here to the Kangaroo and keep going, I just ran a wire to the Arduino right from the battery connector. So it's close to the battery, doesn't have any noise. It doesn't come from, after the Kangaroo and the Sabertooth. Excuse me, I just hooked it right up to the battery. So here's a bunch of plugins requiring updates. Let's do them, because I know that they're mandatorily good. Yeah, what David's talking about with having the ground is super important. If you don't have a ground and you're hooking two PCBs together, then you're not hooking two PCBs together. You're something's gonna blow over time, and nothing will work at all, because it's gonna try to look for ground to complete the circuit through one of your other wires. Okay, so the three plugins we had to update here is for the Intel Realsense. This is for doing some navigation, and of course the navigator. And oh yeah, there's an update for ARC. I'm definitely going to perform that update because there are some bug fixes and some performance improvements that we want to experience. Hopefully no new bugs, Perry. Hopefully no new bugs. We test the crap out of it to make sure that we don't get bugs. But if there is, we'll fix it right away, as always. It doesn't take very long. The click to update feature, yeah, it's super nice. There's another one that I was working on where you didn't have to even click next or anything. It would just do the update silently in the background. But the problem with it was you didn't know if it was succeeded. You didn't know if it was happening. Well, that's really nice to hear, Barry. He says there's very few bugs in ARC. That's good. It's nice because some people come on the forum and they say, your program's not working. It's like, no, your program's not working. ARC is fine. You're just trying to do something weird. Yeah, we have the biggest thing we use Exosphere for, minus the customers that use it for their stuff. But for us internally, we use it for testing. So every single time we do ARC updates, they run on those robots, and it's awesome. It's a real good way for us to be able to prove that the software works before we give you guys an update to it. It is hot in here. Oh, we got here today. The office temperature furnace was set for, what did I say, 24 degrees. Somebody must have been in here with no pants on or something to be that cold. Oh, it is. And I'm wearing a hoodie. And it's hot. And then, of course, we're in the lab. And the lab is just like a little tent. Jeremy and I are sharing a little tent. What bugs do you find, Perry, when you say very few? Are they bugs in ARC or bugs in robot skills? Those are two different things as well. But either way, we're not going to know unless you tell us. I didn't realize these beers are 6%. What's a cider?
It's like 5 or 4.5.
4.5%? Yeah, these are 6.6. Yeah, lockups are weird. Lockups are always weird. A lot of times, actually almost every time you can think of a lockup right now, they're out of our control. We try so hard, because I get a lockup every now and then too, but a lot of times it's because something mid-communications is stopped. And Windows has this thing called a socket. Well, all operating systems have it, Linux, everything. But the sockets that Windows uses is the same sockets that Linux uses. They're based on BSD. and they were developed back when TCP was first developed, and they all use the same code base essentially, and it's pretty crazy. But there's like 3 or 4 ways you can just lock it up because we put so much data through these things, right? So many little tiny packets and such a high data rate. So sometimes we get these issues, and it's like, fight with it, man. Fight with it. All right, Arc, where are you? Pin to task manager. There you are. Booyah. Perry, don't worry about me drinking beer. It's summertime. I'll be doing a lot of that. This is just practice. I'll be at my cabin soon enough. Okay, so project is loaded. Now we're running the latest versions of all the robot skills.
Network connection successful.
Sounds like we have a network connection successful. That's good news. Let's connect to the Arduino. It connected no problem. I'm going to put this robot down on the ground before we start turning on the Realsense and stuff, because there's no point to doing it up here and messing up the everything. All right, so I'll make it so we can see the robot. I'll make it a little bit bigger here so you guys can see what I'm seeing. And I'll move a couple of these robot skills around. And then I'm going to turn off auto arrange. So next time I load this, it's not going to, there it goes, all auto arrange. Turn that off. Save it. So next time it'll just continue on like this. I might move a few more things around because I like the idea of making this window just a tad bigger, so we can see. I wonder if I should put it maybe down under here. Yeah, that's a good idea. Cool mode D. And now I have lots of room up here to put these things. as long as it's beer in my mouth. Okay. Tell you, you know what we should do? Oh man. Thing is, I leave town next week and I'm going to my cabin forever to live like a hermit. So I was just gonna say it'd be really cool. We should have set up a beer bot for hack nights so people like Perry can go get us beer. You can exosphere to go to the fridge and get beer with like an in move. Shit, man, why didn't we think of that? Ah, maybe I could do it when I get to my cabin. Maybe I can make a beer robot. I just have like this high level stair that gets between the deck and the camp, and that makes it difficult. I don't think you'd be able to make a ramp. No way, because then I'm going to forget there's a ramp there and I'm going to trip and bail. Okay, let's go. Where are we here? Let's connect to the Realsense. Oh, I noticed this happens. It says pairing unable to create device. I wrote a bug report on Intel Realsense, and I think they said they fixed it actually just a couple days ago. So what you have to do sometimes is you have to actually either close this down or restart, or so close down the D335 and re-add it. Not all the time, just sometimes you have to do that. Oh, garbage. I had auto range turned on. Man. Way to ruin Christmas, DJ. All right, here. Let's put these back. Everyone's in anticipation to watch this robot actually move. Okay, so let's select. Oh, it's still not there. WTF, you. Did I plug you in? Let's find out. Oh, maybe I never plugged it in. Hold on, let me just check. Which one is that? That's the D435. Oh yeah, it wasn't even plugged in. There. I heard a ding, ding, ding. The USB cable was partially sticking out. That's better. All right, so let's connect to this guy. And let's take a look and make sure that, I like to have this set at 130. This is the screen that does the calibration of how much of the image you want to convert from a 3D image into a 2D image for the laser scan. You can set this to different heights based upon what you're going to hit. And you don't want to hit any floor, right? Doesn't make any sense to detect the floor. So I bring it up around, I find 130 is a good number. Then you get the horizons far enough away that it's not going to detect it. And we'll connect the T265. That's this guy here. There it goes. And now we should be able to look inside of here. Let's see, where are we? There we are. There is our map. Let's clear it because we just played with it. There, it looks better. And we have the Kangaroo set up here, so I should be able to start driving the robot. And I'll make this, there we go, so we can see the, oops, I have to hide that error. I have that in it for debugging, and I still kept it there. There we go, so we'll drive around. And we'll learn the room. So we're using the new renderer as well on the navigator, so you can see how thick everything looks, and it just looks way better. Yep, there's an option for that. Yeah, the roux seems to be working really good. You'll notice, let's test out the straightness of the roux. So let's turn it around. And we'll drive it back here, and we'll get it to a line. And we'll drive it along the line. Tombstone! Tombstone. So my family is really big into BattleBots. And it's like, we're like rednecks when we start watching that show, man. It goes, we got crazy. We're starting yelling a lot. Tombstone's great. Okay, so let's just make the robot drive forward. I'll set both speeds to 100% on the Sabertooth, and I'll just hit forward, and we'll see how straight it actually goes. This is with the Sabertooth using the wheel encoders and the DC motor. That's looking pretty good. I mean, I wasn't centered 100% on the line to begin with, but the fact that it's driving straight. All right, let's turn it around. And back it up. Back that back up. Yeah, independent mode, David, is way better than mixed mode. By far. All right, so we got a pretty good map that we're making here. Things are looking pretty decent. So while we're here, let's, we did mention that we're going to try out that new camera. So why don't we try out that new camera now? I noticed that the confidence of the Realsense is reading 2, not 3. And I wonder why that is. It's not, usually we get 3, but it seems to be getting only 2 today. Yeah, Perry, you could. You would. The thing about the Create is it doesn't have a distance sensor for for very far distance. It would actually have to get right up to the wall to be able to detect an object. So you could read. I'm going to show you something. There's a command. So you wouldn't be able to do it with the robot skill, the iRobot Roomba skill specifically, because it doesn't read the data. But if your movement does not plot on the navigator, it's because you would need to turn something on. And I'll show you what you have to turn on. So go to the iRobot Roomba movement panel, manual, and in the configuration, there's a button here called NMS Managing System. You have to turn this on. And you'll also need to be using either a hardware UART or a PC COM port. You have to use one of these two. You will not be able to use the serial, this one here, because this does not read data. You're also going to have to make sure that your RX and TX are hooked up correctly so that they're connected together. And once you do that, then you're going to start being able to read data. If you want to see how I got it working, this live hack here it's not very long. It's pretty, well, it probably is long, but there's a part in it you can just go to and you'll see a part where I actually create the wire, the cable, and I hook it up. So I make the cable here and then I turn on the robot skill. So you just have to make sure that the TX and RX are hooked up. Those are the two important pieces. And it has to be, like I mentioned, connected with either the PC COM port or the UART, one of those two. And then once you get that done, then make sure that you hit the start streaming sensor button that's right here. Because as soon as you push that, that will start receiving the sensor data and it'll start pushing it into the NMS. Oh, right here, look at that. There's instructions to do it. I didn't even realize. Everything I just said was already written down. So here's the details. It'll tell you here, turn these on, push the sensor button. Hitting reset is pretty good. Well, if you're getting, the thing is, if you're getting the sensor data, if the data is coming in, and this number here, this 1,300 packets number here, if this number is increasing, then it is getting the data. And if NMS is set up, the checkbox, what these checkboxes are set up here, then the navigator, just add the navigator, it'll start working. Make sure you have obviously the latest updates to everything, but yeah, it works. I know, like, if you talk to Nink, Peter, that's what he uses. He uses the iRobot Roomba as a platform. So does Prodigy? Yeah, I know those two people in the forum use it, so they might be able to help you a little bit more. But outside of that, pretty basic. Okay, so we're going to add in the camera because we want to test out this camera device. Yeah, and Perry, just post in the forum what your results are and some screenshots, like in a new thread or something. Then I'll be able to walk you through and make sure we get it. But it's probably something super simple that was just overlooked. It's hard sometimes when we're working on robots alone. We always, I do it all the time. Like I'll be sitting there pulling my hair out going, what am I missing? And it's always like one simple little thing that I overlooked. Okay, camera device. And let's check out this new camera that I got here. Let's see. Here we go. Oh, I didn't know you can actually detect the real RGB cameras. What? Will this work? Can I select it and hit start? It says initialized, but there's no data. I'm gathering. I wonder if it's because the camera is actually running. I didn't see this before. So the D35. Huh. Let's turn off the D35. Where are we here? It's this one here. Let's turn it off. Stop. Therefore, it's not. There we go. It's not running. Let's see if we can try start connecting to it. Oh, holy! Look at that. We're using the D35 as a camera. Let's. I noticed there's another one here called the depth camera. What's that going to look like? Nada, nothing. That's okay. Yeah, I'm gonna try changing the resolution to something higher, like 640 by 480, because that's the. You know what? It's probably some sort of weird packet of data, like some sort of image data, because it's a depth image that the camera can't process. But I mean, this is using it natively. I don't see why you'd want to do this because it's a waste of a nice sensor camera. Instead, if you want the camera data, just start your camera and then go into configuration, enable a video stream, specify your camera device, and click save, and then go to your camera device, put it in custom mode, and select the resolution and click start. There. So that's that's a better way to do it, because then you're using the camera data between both of these. But that's not what we're going to be doing right now. We are going to use this new camera that I just got installed, and let's check it out. So I like using 320 by 240. It's still my favorite resolution. Let's see what it looks like. That's not bad. I don't know. Does that look like a 110-degree view to you, Jer?
Doesn't seem very bent on the edges or anything, right?
No. Well, yeah, it does. Look at the countertop.
Oh yeah, a little tiny bit.
Yeah. Okay, let's try a few. Sometimes the full range of the sensor is not being used. Yeah, okay, I made it way too small. Okay, I'm just looking at how much you see over here of the side of my chair. So we'll try a few different resolutions here and see what we end up with. Oh, that one gave me way more width. Look at that. I could see all the way to the edge of my shirt, and I can see Jeremy's entire chair. Just to compare, let's go to like 640 by 480. You see that? I lose all of this and I lose Jeremy's chair. So the resolution is dependent on how much. Oh, this one I don't even get my chair in at all. And this one, I bet you guys didn't know this, that different resolutions will cause different number of, not just number of pixels, but how much your view area is, field of view. See there, look at this field of view.
Oh wow.
This one went really far, so I got all of Jeremy's chair plus some. Now let's compare this. Just keep a mental note about this chair and this chair. And let's go to that resolution we were impressed with before, which was 640 by 400. Let's take a look. See, we don't have any of my chair, and we have nothing of Jeremy. So it looks to me that this likes to have some pretty high resolution in order to get the full range of view. That's not too bad. I mean, it's going to be using a lot more processing power than we need. But one of the things we can do with this, let's see, what's our frame rate look like? So 10 frames a second, that's good. That makes me feel okay. What we can do here is we can actually lower this, the viewed frame rate. This is a nice feature I like to use. So you can specify a performance frame rate. So display every, we can make it say every like 6 frames. or 7 frames. And what's happening is in the background, you see we just went up to 17 frames per second. And you're wondering, how did we go? I thought you just selected view every 7 frames. Well, because the video card that you get on a lot of these small computers or laptops can't update the screen quick enough. So the video card is actually adding lag to the video render. So what happens is that option we just changed allows you to be able to only update the screen. So if you look here, you only see the screen being updated every now and then. It allows the screen to be updated, but therefore in the background, it's still running this number of frames. So if I turn on color tracking or something, I'm still getting 15 frames per second for the tracking. What I'm not getting 15 frames per second at is the view. So if we want to make this number even higher from, like, say 16 frames, let's go into here again. I mean, this is going to be unusable, but if we change this to display every, let's say 20 frames, let's see what we get now. Okay, so it looks like the max we're going to get out of this thing is around 16 frames. But if you look at that video is unusable now. Look how slow that is, right? It's like a second, so over a second. So let's go back into advanced and put this down to a number like I said, 5 is probably good for this, for what we're doing. Because remember, we're pushing this thing pretty hard. Like, there's no Raspberry Pi on the planet that would be doing what we're doing with this thing. We got SLAM running, we got depth camera running, plus we got navigation running, we have localization running, and we have a camera feed. So let's take a look at our CPU usage. It's probably not that bad. It's probably around 80%. Oh, and we're also running remote desktop. So, oh yeah, we're only at 66%. That's pretty good. 70%. That's what I expected it to be. I thought around 80, but it's much less than I thought it was going to be. And of course, Windows is doing other things in the background, like desktop window manager, trying to keep up. Okay. Oh, Perry, I never really answered your question. You asked if you can also create a map. Now, the navigator will be working for you with just the encoders, but this is what you're going to see. Watch. I'm going to stop the Realsense. I'll click stop on the D35 camera. And then I'm going to clear the obstacle map. So this is going to be gone. You're just going to see the trajectory. Because the sensors on the Roomba aren't going to give you any information about where the objects are. So you're going to be driving completely blind. Now, the next release of Navigator allows you to import a map. So you can draw actually not even import, you can draw your own map in here if you really wanted to. Or what you can do is, if you can add a sensor to it, like say an ultrasonic ping sensor, then the ultrasonic sensor has an option to publish its information to the NMS. I'll show you that option here. It's under ultrasonic, distance. Here's the sensor. And where are you, sensor? Oops. Holy moly. There. We just crashed ARC. Oh, do you know why? Because I was using the Arduino and I had it set up to, I was using the same ports for the EZB, or not for the EZB, for the Sabertooth. Darn. That's okay. I'm going to make a mental note on the Sabertooth that if something else tries to use the same ports, to not want to bit the shed like that. So anyway, so let me go back into this and show you. So let's go into the ultrasonic. Where is it here? There. Distance. Here it is here. And what you're going to want to do is turn on this send ping results to NMS. Turn that on. Configure these values. Just put your cursor over here to read what they do each do. And this will publish whatever data you get from the ultrasonic sensor into the NMS so you can create maps. It's not going to be as pretty as what you're going to get from, say, one of these distance sensors we're working with, but it'll work. I mean, there's a whole video series I did on that with an adventure bot. Now we have to remake our map. Dun, 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 dun. Let's make it bigger, she said. There we go. I'll save this as is. And what we were doing, we had the camera going. Yeah, let's add the camera. And then we'll do some mapping. Add. Camera device. Boom. And what are we at? USB camera. Okay, this is going to be awesome because we're going to, let's see, let's set our frame rate for 5 we had it set for, I think is good. Nice. All right, let's drive around and make a map. Oh, except the thing is, the robot was facing a weird direction. That's funny. You see what Perry just said? I kind of like what do you call it? Mumbled it under my breath. I wasn't sure if anyone even heard me say it. All right, let's push the reset button that we just created on the Intel 265. We had done that earlier tonight because we're going to reset all the values to 0. I don't know if you just noticed this, but our position just jumped to 0. Let's clear the map because we don't need that anymore. Let's clear our trajectory because we don't need that anymore. Now we are facing this way. This is just going to make it a lot easier for me to navigate with. I like the robot to be facing. I feel like my north is always facing that way. All right, so let's drive.
Were you saying that's what you said before Michael Scott? Or did you get it from him?
I don't know. Good question. So let's see what happens here. I think if you guys recall the last time we used, okay, I'm gonna turn this camera off. I was just thinking we should try using the camera that comes with the D435 anyway. Let's use this one. Yeah, let's use this one. Custom. Cool. There we go. Let's save this project. Oh, and something else we can do is we can turn off that display frame rate value. We don't need that on here when we're using the D435 because we'll just use the frame rate that we're getting because I'm sure it's just totally fine. All right. So I think since I released that update for the Realsense yesterday, for the camera navigation to hit reset, I think there's a bug. And I don't mean like I think there is. There's clearly a bug. Look at this map behind me. What is going on here? This is not, it looks like a devil's face with horns. coming to get us. Okay, I don't know what's going on here, but clearly my reset button is not resetting at all. So I have a feeling that this sensor is being silly. So I'm going to re-add it, and I have to do a bug fix on that. I wonder what caused that. It's strange. All right, so let's start this back up. Now the reason I'm starting it back up again is because we're going to turn this into the home position. Perry says if anyone is interested in turning a crate into a functional vacuum, you can do it with a $14 brush pack and a 3D printer he'd party designed. That's hilarious. Yeah. So people made those things so you couldn't use them as vacuums, and then of course Perry goes out there and builds a 3D printed part. Oh, that's too funny. All right, here we go. Let's clear the map, clear everything, and restart the T265. This should start it back from 0. All right. So we're mapping outside. Whoa. There we go. That's a nice map of the office now, the lab with the doorway. Just going to build up a little bit more information here so we get like a more solid map. Yeah, it looks nice. Cool. Okay, that looks pretty good. What we can do now is we can turn off the build map button here, and the map is no longer going to be built anymore, meaning that as we drive around, it's static. You see? So this is a good idea because there's no point to continually build a map that you've already built once, or especially if you're going to edit it. So now what we can do is we can start telling the robot to go places. So we can click right here and say navigate to this spot, and it's moving. Oh, it's moving really slow. Let's increase the speed that we're moving at here. Let's go to movement. Oh yeah, the forward speed is set for 50 by default. Let's change this to 100. And let's change the turning speed to 60. See what that looks like. That should be double as fast. Oh yeah, it looks better. Oops, we want build map turned off.
Hey, do you have one of those ladles that you can put some water on the rocks with for the sauna?
Oh, does it look like a sauna now, the image?
No, I mean here.
Oh, in here. I know. It is super hot in here. It is driving me crazy.
Should I turn on the fan? I don't know if it'll help. It'll probably just be loud.
It'll be too loud. That fan is loud. Oh yeah. Man, this navigating is so good. I love building maps. I feel like Camp Peavy sometimes.
Yeah, he does like his maps.
Yeah.
It looks like a big boot.
It does look like a big boot.
The old woman that lived in the shoe.
She had so many women she didn't know what to do, Jeremy.
Children.
She had so many children, not women? Oh. I thought she was living the life. The little lady who lived in the shoe. There, that looks better. It's weird. We have like this big pile of snow. It's a chair in front of us. That's what it's saying. Oh. It's seeing the legs for the table. That's pretty funny. I notice a lot of when you watch like slam algorithms and stuff that people are doing using ROS, they use some sort of filter that removes all of the objects that are too tiny. So like table legs and stuff you never see. I don't understand why they'd want to do that. It seems to me like they're focusing too much on trying to make the room look like a room versus actually something that you can't, like obstacles you can't hit. Let's take a look at the values here for the D435. Oops, not this one. This one. 140. I think we're too low. Let's bring it up. Bring it to 120. Maybe 130. Let's try that. Making a pretty big map here. Oh, there's Jeremy's Swiss Chalet. Our Swiss Chalet. Jeremy got it, so he gets credit for it. This is fun. I don't know what it is, but something about just driving around and mapping a room is just fun. Does it look like The Office to you? RoboRad said, huge map. I like it. It would be a shame to throw another That's What She Said reference in there, so I won't. Because you made it way too easy. But that is the title of your sex tape. Okay, where are we here? We are really building a map here. This is massive. What happens if can we see ourselves in the mirror here? Where's the mirror? Is it on the floor or is it, oh, it's too high. We can't see ourselves. Now, I remember the last time we were driving over here, Jer, we lost our location. Remember, things kind of got weird. The T265 localization wasn't able to. I think it's because there was too much whiteness on the walls. I don't think there's enough detail. The office is too sterile. You wouldn't want to drive this inside of a 1980s horror movie psycho thriller inside of a mental hospital.
No hospital in general.
Probably also doesn't like the fact that all these glass windows are here. Okay, now here's the big question, everyone. How close do you think we're going to be? So if I drive this back to the office, back to our starting spot, which was way over here, do you think this map is going to stay the way it is? I wonder. Let's turn off the build map button here. We'll turn this checkbox off. And let's turn the robot around. And let's start heading back. I don't see any. I don't see it updating our location. No, I didn't make it automatic head back. I should have done that. I'm doing it just by hand. Oh, there you go. You see just what happened? That's what happened last time. So that's why I really need Intel to get back to me on the wheel encoder input, because I'm hoping that's going to fix this problem. See, what's happening is in that room we were just in, when we were facing that one wall, the SLAM cameras cannot identify where they are because the wall is white, the floor is white, and there's no detail, right? It can't figure out what's going on. So it gets stuck in this area right here all the time. But you see how it jumped me over to here? That's great that it did that, because it jumped me to here, meaning that it figured out where it actually is. All right. Now let's see if it'll, let's bring it home. Let's right click on here and say, come home. Yeah, it's coming home just slowly because I had the speed set too slow. I should increase the speed, but we'll do that later. I just want to see if it makes it. And there, he made it home. So let's take a look at our movement, and let's speed our movement up here. Let's go from 100 to, like, say 175, and our turn speed can be 100. There, let's try that. That's probably more appropriate values. Okay, so let's bring it back to over here to the entrance, to the doorway. That's a better speed. Oh, it's dragging the battery behind it. It has like a little tail. We're going to leave it. That's funny.
I wonder what that sound was.
Yeah, it had a weird sound when it was coming towards us, and I was thinking maybe it was the tracks just moving slow. But it's a little battery tail. All right, there's our spot we brought it to. That's awesome. Now let's bring it out the doorway. Let's bring it right to here. Navigate. Go. So remember, we're not recreating a new map anymore. Oh, we are. Here, turn that map building off. We might as well keep it on.
Something is in the way.
Oh, it just yelled and said something is in the way. So I tried to drive it into a wall, and it got mad at me. So what I should do is we should write some code in there that turns the robot until it's in a better position and then tries to fix itself. Okay, so let's bring the robot back to here. So we'll say navigate back to here. Go. And we should see it start coming back to the doorway. All right, awesome. Now let's bring it. So we could make a whole, what do you call it? Waypoint, I guess. Where is our waypoint drop down? It's gone. It's not here anymore. What happened to it? Where did you go? Let's take a look. We did a rushed update right before the call. I wonder if we got rid of it by accident. Let's take a look. Navigator, did we hide your buttons? I think we did hide your buttons. Where's your buttons, Navigator? What's going on here? This seems to be behind everything. Bring this to front. All right. What's going on here? Should be a panel someplace. Panel 1, panel 2. Is there a drop box down here called CB waypoints? There it is. Boom. Oh, what are you doing way up there? Oh, interesting. Look at that. Somehow a bunch of stuff got moved around town. I wonder. Let's take a little looky look. How'd that happen? Let's see here. None. All right. Let's look at our panels. All right, it's not in there. Let's see our CB CM waypoints. We know where that is. So it's CB. There it is. What is it doing? It's set up to fill. And what is CB waypoints hooked up to? CB waypoints. Panel. Oh, it's up to something called panel point select. There we go. Let's go to that. Panel, panel, panel. I bet you this is it here. Bring the front. Boom! We got him back. Just got to bring this guy back up now. There she is. And let's bring this back. Boom, 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 boom. Boom. Okay, that looks more like it. That was crazy. Everything was all over the place. So let's do a new build and update it to the server here. Which one are we at? This one. All right. Version 29. Navigator. Build. Zip. Website. Community. Navigator. You have to talk like it's a Japanese movie. Japanese action. They always talk like what they're doing when they do it, eh?
I will kick you in the face.
Kick. Punch. Jump. Karate chop. Hurricane kick. Okay. Uploaded. Let's save our project.
You can blame Mr. Miyagi because he did the wax on, wax off.
Mr. Miyagi, wax on, wax off. Okay, we'll click on and we'll now reconnect to, and we'll upload the Navigator. That's the thing we just updated. So now we should have our buttons and we'll reconnect to the project. And magically, our map is still going to be there. You ready to see this, Magic Businesses?
Did you know that there was 4 Karate Kid movies?
There was 4 Karate Kid movies?
I had no idea. There's Karate Kid 1, 2, and 3.
Huh.
Well, actually, there's more. There's like 5 or 6, I think, actually.
Wow.
New ones.
Jeremy's educated me on the Karate Kids. I know there's a Karate Kid TV show now, right? Like some show on Netflix.
Cobra Kai, yeah, I watched it all. It's pretty good.
Everyone I know has been watching it.
Yeah, it's pretty good.
I keep saying all these words. It is so hot in here. I'm getting sleepy.
I know, me too.
Get over here. Finish him.
I was thinking, oh, did you know the Mortal Kombat's coming up in the new movie?
Network connection successful.
In the theaters?
No, what is it?
It's coming to theaters next month. Or this month.
A Mortal Kombat movie?
Yeah, new Mortal Kombat movie.
Holy moly.
I don't know how they're going to go into theaters when there's nobody there.
Yeah.
Maybe only in Texas, maybe.
There's a lot of movies that people are talking about, like going to come out or maybe come out or who knows.
April 23rd, yeah.
You guys remember, the thing is, you always want to start the robot where like position 1 was. The only trouble with this is I don't remember where position 1 was. As soon as I turn on the map, it's going to be all weird because I didn't start the robot in the right spot. I should have marked it on the ground. Well, there's our map. And I have a suspicion that it's going to be really messed up as soon as we start driving. Oh yeah, it's upside down. Oh shit. So now we have 2 labs. We have a lab beneath and a lab above. We have labs for days. So if there's a bug in the reset button, where is that bug? And how? How is it being a bug? Let's find out. Let's clear the map. And so right now where the robot is sitting, this should technically become position 0 if I push the reset button. So if I push the reset button on the Intel Realsense on this thing here, the robot, this here should jump to position 1. Boom. There. Okay. Clear a trajectory. Clear obstacle. All right. And now, according to the compass, well, it's not really a compass, but according to its degree heading, which way it's facing 0 degrees, which means that moving this way should be 0 degrees. So if we start driving, what happens? Yeah, see, that's not right. That's not right at all. There. No, you can't wreck the map any more than it is, Jared. I wouldn't worry. There's a bug when you push the reset button. So what's happening is, for some reason, it's putting it thinks I'm driving this to the right. This is north. 0. So that's what's happening. It's getting bonkers information for some reason. I'm going to have to fix that tomorrow, not tonight. Oh. Okay, so
What's your prediction?
predictions, everybody. Place your bets. What do you think the battery voltage is going to be?
Okay.
We're going to check.
Okay.
Here we go. Oh, no! I was totally off. 75%.
Yes! Yes!
Jeremy won.
Woo!
I wasn't guessing that at all.
I went over though. If we were playing Price is Right rolls, I would have been bust.
Huh. Well, it is running a computer though, Alan. This is running a full-fledged Windows 10 PC on here. And it's been running for 3 hours straight. At like what, 70% CPU?
Running like 3 webcams. Like,
Yeah, it's running 3 webcams and SLAM and navigation. Like, it's been running a lot of stuff, plus tight VNC at the same time. So,
how hot is the heatsink?
oh, it's not hot at all.
Wow.
Yeah, feel it. Put your hand on there, Jer. You want to grab the gun and see?
Yeah, I'll grab the gun. Oh wow.
Yeah, Jeremy's going to grab the gun. So, this is something that I mentioned on the forum that Peter and I were talking about too, is that this heatsink, you have to mount these things upside down like this. Jeremy's checking. Wow, that's it? 40 degrees? No.
That's low.
Well, I guess that's probably right, eh? Because if you put your hand on there,
Really warm to the touch.
it is barely warm to the touch. Wow. 40 degrees. Huh. Cool. Cool. So 3 hours, 74%, like super serious CPU usage. Tons of peripherals hooked up to this thing. Like look at the number of cameras we got this thing. Right? It's a monster. So how many hours is that? So 75% we'll say, so that's 3 hours for every 25%. So what's 3 times 4?
12 hours, half a day.
12 hours. I did say that I get about 12 hours out of this battery. I've only actually ran it, I think the longest I ran it for is about 8 hours. So this button here is actually a shutdown button. Did you know that? If you set up Windows, by default it'll be set up as sleep mode. But if you just go to power options in Windows and you can change it for shutdown. Then I have ARC set up so that it doesn't prompt you to shut down anymore, right? Just go to preferences. When I push this button, watch ARC on the screen here. Watch. Click. That's it. So I don't even need a monitor hooked up or anything for this robot. I can just run it however I want and just push the button and it shuts down automatically. Yeah. And there's a light on underneath. You can't see it, but there's a little light that actually turns on once it turns off. So I know it sounds weird, but there's a light. Do you see that light? That turns on when it turns off. Yeah, it's some sort of light, and then you just disconnect the power. And actually, if you don't disconnect the power, it'll be fine. This will detect eventually that there's no power being drawn, and eventually this will just turn itself off. Okay, everyone, take care. I'll see you guys on the forum. Thanks so much for hanging out tonight. It was a lot of fun. All right, bye-bye.